So now we will discuss about our next topic of uh, our course, that is petroleum industry. So petroleum industry is a very huge industry. It has petroleum as well as petrochemical industry. It will take lot of time to cover all the each and every point. So I will try to cover as much as possible in the class or session. So start with basic introduction about the petroleum. So petroleum is also known as crude oil. It is a naturally mixture of hydrocarbons, right? It has mixture of various types of hydrocarbon. Those are in liquid state and that may be include other impurities like sulfur, nitrogen, oxygen compounds and metals and other elements as well. So the color of the crude oil, it varies from light brown to dark brown, even as black also. So the inorganic sediment and the water also may be present in the petroleum crude oil. A petroleum product is any product that is manufactured during the petroleum refining. Consequently, it is not surprising that the petroleum can vary in composition properties and produce wide variation in refining behavior as well as product properties. So the petroleum means literally rock oil, okay, and it refers to hydrocarbons that occur widely in the sedimentary rocks in the form of gaseous, liquids, semi-solids and solid. It occurs in the sedimentary rocks in the form of gases, liquid, semi-solid and solid. So from a chemical standpoint or from the chemical point of view, petroleum is an extremely complex mixture of hydrocarbon compounds, usually with minor amounts of nitrogen, oxygen and sulfur containing compounds, as well as trace amounts of metal containing compounds in it. So the petroleum products are classified into, there will be light distillate, we will be discussing in the petrochemical more. So it has light distillate like LPG, naphtha, gasoline, middle distillate that is kerosene, diesel, aviation, turbine fuel and lube oils, and also it has heavy distillate that is wax, bitumen, petroleum coke. Next, we will discuss briefly on the origin of petroleum, how the petroleum was formed. So, petroleum oil and as well as associated natural gas were formed 100 years ago, that we all know, from the prehistoric plants and animals. It is believed that the hydrocarbon formed by the thermal uh, thermal maturation of the organic matter that is buried under deep in the earth over the millions of years under extreme pressure and high temperature. These organic matters are converted into hydrocarbons that has oil as well as gaseous compound. So these hydrocarbons are present in variety of forms. One is kerosene, asphalt, crude oil, natural gas, condensate, and coal in solid form as well. So this kind of from the prehistorical time we are having this kind of hydrocarbon which is formed by high pressure high temperature condition. So these has some forms like kerosene, asphalt, crude oil, natural gas, condensate, coal in solid forms. So the three components were needed for oil formation: source rock, reservoir rocks and cap rocks. Mainly the kerosene are present in the cap rock, that is limestone, sandstone and shale. Kerosene are present in the cap rocks. So they are found in sedimentary rocks. Sedimentary rocks are limestone, sandstone, shells. There are few theories. There are two theories for a production of formation of petroleum. First theory is carbide theory or inorganic theory. Next theory is organic theory. Now coming to the first theory, that is carbide theory. The carbide theory or inorganic theory, the hydrocarbons present in petroleum are formed by the action of water or inorganic carbides. Okay, so they are formed by the reaction of metal and carbon under very high pressure and high temperature condition under the earth. These lower hydrocarbons then undergo the hydrogenation and polymerization reaction to produce various types of hydrocarbons. However, this inorganic theory fails to explain the following facts. This is not the accurate theory for origin of petroleum because it doesn't uh, showed how if it is only the inorganic materials are involved in whole formation of petroleum, then the presence of nitrogen and sulfur compounds, how those are present in the petroleum, how the chlorophyll and hymine is also present in the petroleum, how the presence of optically active compounds are found in the petroleum. So this is not only inorganic compounds are present, but also other sorts of organic materials are also present. Those are not covered in this theory. So this theory is not perfect, which they perfectly it doesn't perfectly describe the origin of petroleum. The next theory comes, that is organic theory. So according to this theory, on dying of the marine organisms sink to the bottom of the sea and these are buried. Later on, the sea shores recede, leaving this deposit remains as a surface layer on the land. Now, geological variations, various deformations, faults, and other things, geological variation result in covering these remains by layers of mud and causing the marine deposit to be buried deep below the surface of the earth. Now the mud accumulates on the thick layers containing those organic matters buried and causing the high pressure, high temperature conditions. At such conditions, the bacteria, possibly the radioactive transform organism, by fermentation process, they convert the organic matter into hydrocarbon in the forms of gas or oil. So the organic theory explains the presence of nitrogen and sulfur compounds, also the chlorophyll and optically active compounds. So this organic theory is widely accepted theory. Next we will discuss about the occurrence or reserves of crude oil. So, the occurrence of the crude oil under the earth crust, it is like underground traps of oil and gas. Those are called reservoirs of crude oil, right? This the most reservoir contain water also, along with the oil and gas. Reservoirs are classified as proven, probable, and possible reservoirs. So these are some terms in the geophysics. They do lot of studies on this kind of reservoirs and of the crude oil, the possible extraction of the oil from the reservoir and all. So there are various types of traps, um, structural trap, stratigraphical trap, and combination of the traps from in which we find the occurrence of the crude oil along with natural gas. So the petroleum traps are below the ground traps where a permeable reservoir rock is covered by some low permeability cap rock. Once the oil and natural gas are in the reservoir rock, they continue to migrate upwards through the pore spaces of the rock until they get blocked by some sort of seal with the cap rock. There will be stopped in the migration of oil and gas further. The low permeability of the cap rock are generally shale or the low permeability sandstones or carbonate rocks. So this is two kind of a trap we can see. This one is kind of structural trap. Okay, so you can see this is the impermeable rock, and this one is the rock oil. Also, B is the porous reservoir, and C is the source rock. So here, from here, by temperature and pressure condition, the oil and gas will produce, and eventually in this porous reservoir rock, so the oil and gas will migrate upwards, and at a certain point it will block because this gray layer is nothing but this is impermeable. So in between, this is the natural gas will be lower in density, so it will be in the top, and the at the bottom there will be rock oil or the petroleum oil will be there. So this is the um, anti clinal trap. So the structural traps are types of the form that result some structural deformation of the uh, rock. So there is some structural deformation, and it forms like this kind of capping thing. Otherwise, it could be like this kind of arrangement, layers of rock. But due to the deformation of the length or the rock, there is some formation in the uh, caps are produced like this due to the pressure, or some deformation of the land occurs. Due to that, there is this kind of trap it generated. So the source rock that is rich in the organic matters and that have been deposited in a variety of environments. Okay, so the with increasing in the burial matter or the later sediments or increase in pressure, temperature condition, the kerosene within this rock source rock begin to produce the it produce the fluids, gas or liquid, and through the pores it will migrate. Internally it will migrate, and it will when it will be facing a impermeable rock, and then it will start accumulating. This cannot go or penetrate further. So similarly, it is occurring here. It is the stratigraphical trap. So it is also. This kind of rock is also like same at the bottom. At the top, it will be having gas, natural gas, and at the bottom, it will be rock oil. So this kind of structural trap or stratigraphical trap, these are all depend on the various kind of land deformation occurring. It is depend on that thing. So next, we will be discussing about exploration of the crude oil. How the crude oil, when we already know that how the crude oil is situated under the earth inside the trap, different kind of trap. So we need to explore, or we need to do the production of that crude oil from that trap. So the exploration of the crude oil, there are few methods for exploring the crude oil. First one is geological method. In that, there is subsurface mapping, that is the selection and mapping of the promising area which satisfy the criteria of being sedimentary rocks. We generally find the sedimentary rocks because it has certain properties with presence of anticline structures. So they are expressed in terms of known geographic locations, stratigraphic traps and rock compositions at depth. So this kind of surface mapping, we use the contour maps for doing the surface mapping, subsurface mapping. Next one is the remote sensing, the scanning of the earth by satellite or high flying aircraft in order to obtain information about information about the occurrence or situation of the sedimentary rocks. So these data are highly useful as an integral tool for downstream and upstream oil and gas operations through evolution of infrastructure for well site planning and for well exploration through the large scale. So spectral analysis is a key form of processing to evaluate the surface outcrops and surface hydrocarbons. Next one is the geophysical methods. In it has the gravity technique. So it measures the gravitational field, and these readings correlates with the density of the region. So it provides the information regarding the underlying formation of oil, basin shape, sedimentary rock thickness and all. Next one is the electrical technique. This technique responds to the resistivity. Okay, so it measures the electrical properties of the subsurface, such as resistivity and conductivity, which can vary significantly between different rock types and different fluids. Such examples of the electrical technique is DC resistivity, induced polarization IP technique, and electromagnetic methods. Next one is the magnetic technique. So the magnetic intensities of the rock and their distance from the surface is measured by the magnetometer. Either in the ground or in the air, we generally measure the magnetometer. And why it is used? It is used to locate the sedimentary rocks, because these sedimentary rocks have very low magnetic properties than other rocks. So by differentiating this way, we generally use the magnetic technique as well. Seismic technique. So it is conducted by it is responded to the velocimetry. So it is conducted by the sound waves. It indicates the nature of the rock and the angle of dip. It is used in onshore to detect the echoes that is returning from the ground, which is being sent to the sea or geophones or hydrophones. So they are sending the sound waves, and however the echoes are they detect by some arrangement. So this is kind of seismic study or seismic survey. So next one is the geochemical method. So there is direct method. It involves the presence of the dispersed oil components in the form of hydrocarbon or bitumen in soil, rock, water in the vicinity of oil and gas accumulations. So this method includes gas logging, bitumen survey and hydrochemical. Indirect method. It is based on the detection of any chemical, physical and microbiological changes in the soil, in the water, rock associated with the gas and oil deposits. These methods include soil salt method, oxidation reduction method, microbiological method and hydrochemical method. So these are the three methods, geo geological, geophysical, and geochemical methods for exploration of the crude oil. Next, the topic will be production. How we will do the production after exploring the um, position of the field of crude oil possible exploration we can do. Next we will move forward the production of the crude oil. So the selecting the site for the drilling requires detailed knowledge of the geographical features that we do in the different survey that we already discussed under the earth's surface. So drilling is done to determine the extent of the reserves, oil reserves. So the drilling process include first the site selection. Here the geologist and engineer analyze the geological data to identify the potential oil bearing areas. Factors considered including seismic data, well logs and geological maps. Next, when the site selection is done, then there will be rig setup. So in the rig setup, a drilling rig, that is a very complex piece of machinery, is assembled at the chosen location. The rig consists of derrick, drilling equipment and other necessary components to drill the section. Then the drilling operation starts. A drill bit is attached at the end of the drill string and lowered into the ground. The drill string rotates and causing the bit to cut the rocks and create a borehole. Now the drilling fluid is circulated down the drill string to remove the cuttings as well as lubricate the drill bit. Then reaching to the reservoir. Once the borehole reaches the oil bearing formation, up to the oil bearing formation, the drilling fluid is replaced with the production casing. The drilling fluid is replaced with the production casing. The casing is cemented in place to prevent the fluid leakage and provide the structural support as well. So this is the process of drilling operation. Then at last when it reaches up to the oil formation zone, the production occurs. The oil and gas flow naturally comes to the surface due to the pressure difference within the reservoir. If the natural pressure is insufficient, then we have to introduce the air artificial lift method such as pumps or gas injection may be used to enhance the production of uh, natural gas. So there are three different types of drilling. First one is the vertical drilling, that is the most common method, and where the borehole is drilled straight down. Horizontal drilling, the borehole is drilled at an angle to reach the target formation, that is laterally extension. And then directional drilling, this is the combination of vertical and horizontal drilling to reach to the specific target. So next we will discuss about the composition of crude oil. So broadly it has hydrocarbon and non-hydrocarbon part. In the hydrocarbon, it has specific things like paraffins, isoparaffins, olefins, naphthens, as well as there will be aromatics. And non-hydrocarbon, this has compounds, nitrogen compounds, and oxygen compounds. So, briefly we will discuss, not too much extensive. So these paraffins, this has common formula as CnH2n plus 2. Okay, so these are some straight chain hydrocarbons, and it has examples like methane, ethane, butane, etc. Whereas in case of isoparaffins, it has same kind of thing, but CnH2n plus 2, but this has branched carbon chain. This includes isobutane, isooctane, neopentane. Ex- Next one is olefins. So this has general formula as CnH2n. So these are one pair of carbon atoms are there, olefins or alkenes. So example, you can say ethylene, propylene. Next is naphthalenes. This is around 5 to 6 carbon atoms in a ring. General formula, we can have CH2n plus 2 minus 2Rn, where Rn is the number of naphthenic ring. This naphthenes, this includes cyclopentane, cyclic compounds, and also other examples are there. You can check on. other examples as well. Next one is aromatics, which obviously this is not desirable in any case. This has six carbon atoms in a ring. Example: benzene, toluene, xylene, etc. Next one is that we discussed about non-hydrocarbon compounds. So sulfur compounds, it has H2S, mercaptans. Nitrogen compound, it has uh, pyridine, quinone, pyrrole, etc. And also the oxygen compound, it has phenols, naphthenic acid. So these are some various composition of petroleum. So we will limit up to this portion in this class. We will discuss the rest of the portion in the next class on Friday. We will discuss the next portion in the next class of this week Friday. So the next details of the petroleum industry will be discussed in that class. So thank you for today's classes. Up to this, we will meet in the next class. Thank you.